Using Kirchhoff's second law to find the potential difference between 2 points. To begin with, we're going to look at a problem that we solved in one of the earlier presentations. And we're going to find the potential difference between 2 points on the circuit. What we're going to do is we're going to trace the path between the 2 points and add up all the changes in voltages. The neat thing about this is no matter what path you take, as long as you don't double back on yourself, you'll get the same answer. And when you're doing this, if you calculate any type of negative currents, just keep them for the other calculations you may use. So in this example, I've got my points labeled A, B, C, D, E, F, and G, just so I can talk about where I'm going from point to point. My current on the left loop, which is the red line, is negative 0.071. That's what we found out in our earlier presentation. The current in the green one is 0.64 amps, and the current in the right loop, which is the blue line, is negative 0.71 amps. Remember, my negative currents here just mean that when I made my original assumptions, I got them backwards. So the reality of it is the red current goes the other direction and the blue current goes the other direction, but I'm just trying to keep with some continuity and stick with my earlier example. Now with this example, I'm going to use my negative currents in all my calculations, and I'm going to find the potential difference between points A and D on this diagram. So there's the highlighted points there. And I'm going to do it a couple different ways. The first way I'm going to do it is to go over to B, down to C, and then over to D, which is the orange line. So if I look at that one, the voltage from A to D, if I set it up, I get plus 6 volts, and then I get minus 9 volts to go across the next battery, and then I'm going against the current, so I'm going to add negative 0.71 amps times 3 ohms to get that voltage. The next path I'm going to choose, I'm going to go from A to G to F to E, and then up to D. Now when I choose this one and start analyzing it, the first thing I'm going to do is I'm going down with the current, so I'm going to say minus a negative 0.071 amps times 12 ohms, backwards across the 6 volt battery, so minus 6 volts, and then up to D. The third path I'm going to take is from A to G to F to C to D. It's a yellow line that just appeared. So to find this one, the first thing I'm going to do is go across the 12 ohm resistor, so I'm going with the direction of current, so negative times a negative 0.071 amps times 12 ohms. Then I'm going up the 6 ohm resistor, so I'm going with the current again, negative 0.64 amps times 6 ohms, and then from C to D, across the last resistor, negative 0.71 amps times 3 ohms. And then when I calculate the voltage using all my methods, and of course if I kept all those decimals from before, everything would match just fine, and I get negative 5.1 volts no matter which path I take.